guys, so this is the second in my videos on Kc, and this is Kc for intermediates. And the most important thing for you to remember today is a visual image of a Barbie doll ripping the head off a Ken doll. Maybe hacking it to pieces with a chainsaw. I'm sure I did that then. Or possibly nagging it to death or something like that. So if you can remember this picture, by the end of the day, then you probably remember how to do what we're going to talk about. And what we are going to talk about is how to calculate Kc when the examiner gives you your starting number of moles of your reactants and products. So I've got an example equation here. 2a plus b reversibly goes to 3c. And all we're going to do is go through these 4 steps, one at a time, in order to calculate our Kc. So the first thing we're going to do is we're going to look at our data, look at the information given to you by the examiner. Now, I haven't written the question on the board because I haven't got enough space, but let's pretend the examiner said we have 4 moles of A, 5 moles of B, and 0 moles of C. And this will be our starting moles. This is the moles we start with. And what you'll have to do is rip those numbers out of the question, because I'll probably put it in a big paragraph, and you just have to take them out and set them out in this format. It really helps if you set them out like this. So put the numbers under the thing it's talking about. In the examiner's question, they'll also give you one of the equilibrium moles. Remember, that's the important thing, because Kc only works at equilibrium. So let's pretend the examiner said we had 2 moles of A at equilibrium. That's your first step, that's your data step. What we need to do is convert all these other starting moles into equilibrium moles. And the way we do that is by looking at our balanced equation. So you can see it's a ratio of 2 to 1 to 3. Now, if I look at my start moles and look at what I need to do to convert that into my equilibrium moles, I see that is a difference of -2. Now, looking at my mole ratio, every time A changes by 2, B will change by 1, because it's a 2 to 1 ratio. So if A has changed by -2, B will change by -1. So 5 minus 1 is 4. Now with our products, if your reactants are losing moles, that means they're being changed into products, so that must be gaining moles. So if these are negative numbers, your products will be a positive number, and vice versa. Another little point as well, if they don't tell you the starting moles of products, just assume it's 0, because you don't usually start with product, you start with reactant. So I've started with 0, it's a 2 to 3 ratio, that is changed by -2, so this will change by +3 to give me 3 moles of C at equilibrium. That's my second step, that's my balance equation. Step 3, we need to convert these equilibrium moles into our equilibrium concentrations. Because if you remember from our last video, Kc is all about the concentration of stuff, not the moles. So we're going to use the equation concentration equals moles divided by volume to change these moles into concentrations. Now, you'll always be told the volume. It'll say the volume of the reaction vessel is decimeters cubed. All you need to do is pop in the numbers. Often the volume will be 1, and that makes it dead easy. Sometimes it's not, and we'll talk about what effect that will have later on. But just for simplicity's sake for now, let's say a volume is 1. Well, any number divided by 1 will just be the same number. So I'm going to do 2 divided by 1 to give me 2, 4 divided by 1 to give me 4, 3 divided by 1 to give me 3. If the volume was 2 decimeters cubed, I'd just do 2 divided by 2, 4 divided by 2, 3 divided by 2, and so on and so on. Okay? If it was 0.5 decimeters cubed, 2 divided by 0.5. Okay, you get the idea. So I've simplified it here, but in the exam, it's not always 1. You have to look out and check what it is. So that is my moles. I've converted my equilibrium moles into my equilibrium concentration using this equation here. What I then do is bang it all in my Kc expression. So my Kc expression will be C to the power 3 divided by A to the power 2 times by B. So let's stick our numbers in. We know that C is 3, so that's 3 cubed. I know that A is 2, so that's 2 squared times by B, which is 4. Now, using my incredibly mathematical mind, I think that comes out at 1.69. Okay, so what that tells me is the Kc is 1.69. That's quite a large number. That's quite a bit greater than 1. And what that means is your equilibrium concentration of products is quite a bit higher than your equilibrium concentration of reactants. Remember, this is all at equilibrium only. In terms of units, which they would expect you to put on the end here, I've got 3 moles per decimeters cubed on this side, 3 moles per decimeters cubed on this side, so it would cancel out, so I would write no units. But you have to actually write that. Don't just leave it blank, put no units, and then you get an extra mark for that. Probably 2 or 3 marks for that question there. Let's say 3. And that is how we calculate Kc. Now, how are you going to remember these 4 steps? Well, how you're going to remember them is by picturing Barbie ripping off Ken's head. Data, did, balanced equation, Barbie, moles, murder, and when I do that with my class, I let them in their own word there, which begins with them, so you can have a bit of fun with that. And Kc, obviously Ken. So did Barbie murder Ken? Data, balanced equation, moles, Kc. Okay? And that is Kc for intermediates.